1029 says a medical team investigated the relation between immunological factors and survival after a heart attack. Blood specimens from 213 male heart attack patients were tested for the presence of antibody to milk protein. The patients were followed to determine whether they lived for 6 months following their heart attack. The results are given in the table. So if their treatment was positive, of those, 29 died within 6 months and 80 were alive. And then if their treatment was negative, then 10 out of them died and 94 were alive after 6 months. Says, let D and A represent died and alive respectively, and P and N represent positive and negative antibody tests. Calculate. So this part A says probability of died given P. Okay, probability of died given N, probability of P given D, and probability of P given A. Okay, so D given P. So this means we are doing 29 divided by 109. So if we know that they were positive, that means that we're limited to 109. What's the probability that they died? 29 of those died. Okay, so this is going to be 29 divided by 109. That's 0.266. Okay, what's the probability that they died given that their treatment was negative? So here we're dividing by those who had a negative treatment, and only 10 of those died. So here, probability that they died would be 10 divided by 104, or 0.096. Probability of having a positive treatment if we know that they died. So here we're limiting ourselves to just those who died. There's 39 of them. And the probability of them being positive would be 29 divided by 39. So that's different from, notice the difference between the probability of died given that they were positive, D given P, versus the probability of P given D. Meaning this time we're limiting ourselves to the 39 and we're looking at the 29 who died. And so this is going to be 0.744. And here, probability of having a positive assessment given that they stayed alive. So 174 were still alive, and 80 of them had a positive treatment. So 80 divided by 174, 0.460. Okay, so that is part A. Part B says the chi-squared contingency table chi-squared statistic, okay, chi-squared turned out to be 10.27. Okay, test a relationship between the antibody and survival. Use a non-directional alternative. So here, the non-directional alternative means we're going to use the not equal to sign. Okay, and so here P1 and P2, okay, P1 could be the proportion of those who died given positive. So we could be comparing these two groups, okay. These could be P1 and P2, or we could be comparing these two groups, and these could be P1 and P2, okay. But we cannot compare this P1 with this one, or this one with this one, or this one with this one. It's got to be these two being compared to each other, or these two being compared with each other. Okay, and so non-directional alternative, so we look up 10.27 with 1 degree of freedom in our chi-squared table, and we see that that number is going to be between, so the tail probability is going to be between 0.01 and 0.001. Okay, 0.001 is 10.83, and 0.01 is 6.63. Okay, so the tail probability is probably going to be closer to 0.001. And because it's a non-directional alternative, the tail probability is the p-value. So our p-value is going to be less than 0.01 but greater than 0.001. Okay, and at alpha equal to 0.05, this means our p-value is smaller than alpha and we reject the null hypothesis, meaning that the proportion of those who either died or whatever is different for the positive group versus the negative group, okay? Or the proportion of those who are the positive treatment, if we use this test, the positive treatment is different for the groups that died versus the group that remained alive.